All right, so hello, I'm Daniel Gwilt, also known as Captain Dan, and today I'm going to be talking about artificial intelligence. And as you can see, I'd like to title this talk, To Give Birth to Gods. We're going to get into what exactly that means here in a second. So, I was very blessed in about the 7th grade. I had a substitute teacher, and he was a reporter, and he was able to get into a helicopter in World War II and was able to take pictures and report on the bomb of Hiroshima. So as you can see here, this is where the nuclear warhead was dropped, and he went right over ground zero. And he noticed that on the asphalt, the road, there were these white streaks on the black tar. And he would see them, they were kind of spaced out. There was two together, sometimes 3 or 4 were together, and then sometimes there was one on its own, and they were almost random. He was like, what is that? So he finally asked the officer he was sitting next to in the helicopter, and he said, what are these white streaks on the roads? And the officer looked at him. He said, well, those were where people were. You see, the nuclear warhead, when it went off, it was so hot that people were vaporized instantly. And you could see where there were families, kids, and everything. And that really hit him really hard in the guts when he saw that. But we're not here to talk about that. We're here to talk about artificial intelligence. So I'm going to play a small video. For audio, I'm going to put it over here. So we're going to try to link this up here.
How could you be worthy? You're all killers.
Stark.
Jarvis.
I'm sorry, I was asleep. Or I was a dream.
Reboot. Legionnaire.
Yeah, it was
Got a buggy suit.
Terrible noise. And I was tangled in strings. Had to kill the other guy. He was a good guy.
You killed someone?
Wouldn't have been my first call. But down in the real world, we're faced with ugly choices.
Who sent you?
I see a suit of armor around the world.
Ultron.
In the flesh. Or no, not yet. Not this Christmas. But I'm ready. I'm on mission.
What mission?
Peace in our time.
So I know the audio was really bad there, but basically, I don't know if you guys have ever seen this movie. It's from a comic book series called The Avengers, and this is a character, an artificial intelligence character, who, as you can see, is not exactly a good one. Hollywood always makes it black and white. He's out to eventually destroy the world, and it's not going to be like that when I think it's going to happen, but we're going to talk about that in a second. But first, I want to talk about what exactly is artificial intelligence. So there's two kinds, and the one that we're probably going to be seeing today is probably not what you think about when you think about artificial intelligence. We call it weak AI. It's made to solve a specific problem with large amounts of constraints. So in this example, we have chess, right? The constraints are, it's a game, it has very specific rules, there's only so many tiles on the grid, and each piece has only so many moves it can make. It has no context of the problem it's solving. It doesn't know why it's solving it. It just tries to solve it. Very mathematical. So how does it do that, right? Let's take a look at our human brain. It's an amazing, amazing thing. It's got over 86 billion neurons, and it can do 1 billion calculations per second, or about 1 exaflop, which is a 1,000 petaflops. So to put that in perspective, the world's fastest supercomputer, the Fungaku, is 442 petaflops. There's a little bit of a gap there. There's about 100 trillion connections between the neurons. So you can see over here, they're kind of like touching each other. Well, an AMD EPYC ROM, which is the most powerful server CPU, in the world has 39.54 billion transistors. It's a lot, but not anywhere close to 100 trillion. So at the end of the day, let's talk about these neurons, right? Because this is what allows you to think. And it's the network between each neuron that creates who you are. It's pretty amazing to think that if you were to adjust that network in your brain, you would change what you remember, you would change who you are, your whole personality is just a neural network. So you can see here just kind of a quick overview. You have on the left side, you have dendrites. Signals come into that. They get processed here in the nucleus and then shot out through the synapses onto another one. That's all it is. Seems kind of simple when you get down that small. So to create AI, or deep learning via neural networks, we've mimicked that. So here on the blue side is going to be the input node. So instead of neurons, we have nodes. And over here are the output. So an example of that is a picture. So maybe we'd have a large picture of pixels. Maybe there's 256 pixels, so very small picture. And you'd have 256 nodes, and each pixel would go in as input. And then it would go through, and there would be weights on these edges here. And that would change, so like if it was black, that would be hit a weight. It would be processed through a function called an activation function in each node. It would be modified, that number, and eventually it would be over here, be yes, this pixel is heading in the probability of being, for example, a circle, or no, it's not a circle. So it's very high level overview. So that's kind of like how we do it, and you can dive into this. Like the engineering behind it is what allows us to do all of the things you think about when it comes to modern AI technology. So let's talk about some of the things that we can do. Got another video. Let's see if we can get the audio to work.
Biggest retailer, and its CEO Jeff Bezos is the world's richest man for one very good reason. His company is better than anyone else ever at giving people what they want quickly. Amazon acquired its undisputed status as the heavyweight champion of the retail universe thanks largely to its lightning-fast delivery times. The astonishing feat of ferrying hundreds of millions of items, from guitar strings to saucepans to car parts, directly to your door inside 24 hours is nothing short of a modern logistical miracle. So how does Amazon do it? A super smart army of slave robots, for one. Ingenious, if occasionally unscrupulous, management practices are part of the answer too. And the modern-day voodoo of deep learning AI, all of which are made flesh in the most advanced stockrooms the world has ever seen. So join us today as we button up our high-vis jacket and journey inside Amazon's smart warehouses. In the year to September 2020, with the global economy in the teeth of coronavirus and the bleakest employment outlook in history, Amazon reported global revenues of little under $350 billion. That's roughly double what it earned in 2017, by the way, only 3 short years earlier. Not bad for a company which only started trading in 1994. Amazon has built its empire on a platform of sheer, unbeatable convenience for the end user. You, the customer, need a product. So you open the app or have a quiet word with Alexa, and next day, hey presto, it's sitting on your doorstep. Moving products from A to B quickly is not easy. Compared with other modern technology giants which barely need to exist in the real world, think of Netflix, Google, or Facebook, Amazon needs to shift an astonishingly vast amount of sheer bulk safely, precisely, and quickly, all day, every day. So how does it do it? Last year, a senior Amazon executive described Amazon's warehouses, rather poetically, as a symphony of humans and machines working together. How does this symphony actually work? Let's take it from the top. Before you've even logged onto its website, Amazon has a fairly good idea of what you're going to buy. This is all down to the semi-occult 21st century abracadabra that is deep learning AI, which Amazon has been leveraging to incredible effect since around 2015. Put simply, an algorithm makes some assumptions about you based on your age, location, socioeconomic background, and purchase history. It will then, hours, days, or even weeks before you actually log on, ensure that your local warehouse is stocked with appropriate quantities of stock you're likely to consider buying. This might be a certain style of racy swimsuit that the algorithm anticipates will be the hot new must-have come springtime. It might be the paperback novel for a soon-to-go viral TV adaptation. In January 2020, for instance, Amazon's algorithm correctly anticipated high incoming demands for face masks, and, well, we all know what happened there. So Amazon's smart warehouses, also known as fulfillment centers, not to be confused with their post office-style sortation centers, very often know what you want even before you do. Or at least they know the very second you click Buy Now in the case of those wine-inspired late-night impulse buys. Once you've clicked, our symphony begins in earnest. You may have read headlines in recent years suggesting Amazon workers walk as many as 12 miles per shift, darting about between shelves, frantically picking up items. That's no longer quite true. Amazon's modern fulfillment centers are largely patrolled by an army of squat, Roomba-like robots that pick up whole shelves, also known as pods, and bring them to a human picker situated at a stationary workstation. Amazon's enlistment of this whirring battalion began in 2012, when the company purchased robotics company Kiva Systems, the market leader in warehouse automation, for an eye-watering $775 million cash. The company's flagship model, commonly referred to as Kiva, is around 30 centimeters high and capable of lifting 450 kilograms in weight, whilst traveling at around 3 miles per hour. The substitution of these squat orange automatons in place of dashing human workers makes a colossal difference to Amazon's bottom line. It's been estimated that Amazon's warehouses can now hold 50% more stock and retrieve that stock 3 times faster. This reduces the overall cost of fulfillment by some 40%. Cheaper, quicker warehouses mean products that are more affordable for the end user, and crucially, products that are much more likely to be on the van driving down your street the following day. Amazon isn't about to stop there. In a move that could be described as either ruthless or inspired, upon purchasing Kiva, Jeff Bezos changed the name of the company to Amazon Robotics and told all previous Kiva customers, household names like Gap, Walgreens and Staples, they'd no longer be allowed to buy new Kiva technology. This, of course, gives Amazon an incalculable competitive advantage. Since rolling out the Kiva robot across its fulfillment centers, by 2018 they had 100,000 of them, by now that figure has comfortably surpassed 200,000, Amazon Robotics has been refining the design still further. The new iteration of Kiva, known as Pegasus, is 10 centimeters shorter, meaning more can be stocked on top, and uses half the parts, so it's cheaper to manufacture and maintain. Amazon says Pegasus can lift a hefty 600 kilograms and can be customized with a conveyor belt to work in the sortation centers, where, Amazon reports, errors in delivery have been halved thanks to Pegasus. Naturally, Amazon isn't quitting there. Last summer, it announced a newer, thinner robot still called Xanthus and coming to a fulfillment center near you. So how do these pimped-out Roombas get around without knocking into each other all the time? Cloud-based software, operating what can fairly be described as an AI-run air traffic control network, coordinates the route of every single robot. This is all about optimization. What's the quickest route to get to a product that won't interfere with other robots on their own runs? What's the optimum speed, acceleration, and deceleration? As many as 800 robots can be deployed at any one time on the warehouse floor, although in practice, the numbers tend to be kept lower to avoid traffic jams. When their batteries run low, the robots are instructed to find the nearest charging station.
Right? So it's just a basic example. And this can be seen across all industries, right? This can be like the automation that's available through AI is unstoppable. I mean, self-driving cars, I'm sure you've heard about those. Those exist. They're driving around the US right now, and it's only a few legal hurdles to get that off on that ball rolling. And it just keeps going. So just a heads up, Jeff Bezos, he's the owner of Amazon. He's the richest man in the world. And they are actually working on something called Prime Air. It actually exists. A future delivery system from Amazon is designed to safely use drones to deliver packages within 30 minutes or less. And they're unmanned. So once again, this is using artificial intelligence. All right. This is going to change our economy and what we think about capitalism, right? We're headed towards a abundance that we can only imagine, right? What are we going to do once we get to a point of AI where all jobs are gone? Something to think about. So, and just a heads up, it's not just drudgery work like factory labor. There is AI that you can go at home and download and play with right now that can make music. So that's fun.
This image was taken 17,500 feet above Quantico, Virginia. and covers 15 square miles.
This whole image is at a very, very fine resolution. So if we wanted to know what is going on in any spot along this image, say near this building at this intersection, we can generate a moving image that shows what's going on in the area.
Simply by touching the screen, Antoniades has opened up a window showing a detailed area, while still maintaining the broader context.
And everything that is a moving object is being automatically tracked. The color boxes represent that the computer has recognized the moving objects. You can see individuals crossing the street. You can see individuals walking in parking lots. There's actually enough resolution to be able to see the people waving their arms or walking around, what kind of clothes they wear. And you could pick the location of where you produce these images anywhere in the entire field of view.
Antoniades can open up to 65 windows at once and can see objects as small as 6 inches on the ground.
From even 17,500 feet, the white thing that you see flying around is a bird.
Argus streams live to the ground and also stores everything, 1 million terabytes of video a day, which is the equivalent of 5,000 hours of high-definition footage.
So you can go back and say, I would like to see what happened at this particular location 3 days, 2 hours, 4 minutes ago, and it would actually show you exactly what happened as if you were watching it live.
To create the world's highest definition camera, Antoniades needed to design a new imaging chip. But DARPA, the project's funder, wanted to move fast and keep costs down. So he borrowed technology that most people have in their pockets.
Inside this cell phone, okay, we find a tiny little camera. So if you were to take off the majority of it, you'd be left with an imaging chip. If you were to take 368 of these and make a big mosaic out of them and start shooting images, now you have Argus.
Unlike the Predator camera that limits field of view, Argus...
So this is done using artificial intelligence. There's no way any human being could ever dream of managing that amount of data. And it's all knitted together with weak AI, mind you. This is the weak stuff here, okay? So 1.8 billion pixels is what that image was, all right? And now, I know this seems like, that's got to be brand new, right? Like, that's breaking news, because it's kind of creepy, right? You can kind of zoom in, see someone. So that video was launched January 23rd, 2013. So this is old. Ancient in computer time. Yeah. And 1 million terabytes a day. You can rent that on Google. Doesn't cost that much now. So it's here, okay? So now let's talk about the strong stuff, right? This is the stuff you probably think of when you actually think of artificial intelligence. And there is some good news. Yes, it doesn't exist yet. But I wanted to put all three of these. They're all from the same movie, right? Ultron is the villain. So he takes a destroy all humans approach to the AI. Then you have Vision on the other side. He's what I'd like to say is a good AI, right? And in the middle is Jarvis. He's not quite at human levels like the other two, but I would definitely consider him a strong AI, and Stark works with Jarvis to create both of them. Now, with these three, these guys are all human level, right? You could say maybe smart humans, but definitely at a human level. What I want to talk about is something more than that. So if intelligence is just a matter of information processing, and we continue to improve our machines, we will produce some form of superintelligence. What does that mean? Okay, so if intelligence is just a matter of information processing. So remember, I broke down the human brain into calculations per second, right? So that's kind of what your brain does, right? When you think about something, when you problem solving, you're taking in raw information from your sensory organs, right? Your eyes, your mouth, your nose, your touch, processing that in your brain, and using that to solve problems in reality, whatever that problem could be. Something as simple as walking to something as complex as calculus. So if we can agree on that, and we continue to improve our machines, so 7 years ago, it had that 1 billion pixels, right? Also, if you think back 7 years at what kinds of technologies you were using, I think the easiest way to think about this is your phone. How powerful, how many features did your phone have 7 years ago compared to today? And I think my phone's a good example. This thing's got 3 screens, 5 cameras. It's ridiculous. It's more power than I probably really need. So just something to think about. We're going to dive into that a little bit more. So if we can accept those two things, then there is going to be superintelligence. Well, what is that? Let's dive in. So once again, we're going to talk about, I said the phone, but this is right here is Moore's law. So this is processing power. All right, this is something called a central processing unit. It's a microchip inside of every computer that does calculations. And generally, the number of transistors, which are little things that allow or resist communication between the circuits, right? The more of those you have, basically, the better the chip. Faster it works, the more calculations it can do. And we can see here from 1970, we've been roughly doubling the amount of transistors every 2 years. That's what Moore's law is. And up here, you can't quite see it, but you have the EPIC chip came out here in 2020. So it's very consistent. And there's a good reason for that. It's big bucks, right? You guys saw Bezos. That's only possible on these powerful computers. There's a lot of money here. The other big thing is, it's not just money that's open, all right? There's also raw power, right? When it comes to strong AI. So one thing I wanted to bring up was, will we push to create not only better computers, but AI that can take advantage of that power? And the answer is absolutely, right? If an AI were to be developed in Silicon Valley here in California tomorrow, okay, and it took a month for other nations to catch up, the amount of progress that we could make in that time frame would put us ahead hundreds of years. Because you got to remember, an AI doesn't sleep, doesn't eat, doesn't laugh or cry. All it does from dusk till dawn is solve problems. So with that, we can see here that the world leaders agree. So I'm going to play these two videos real quick.
Интеллект искусственный, но искренность приветствия у аватара самая настоящая.
Уважаемые гости, меня зовут Елена, я виртуальная телеведущая.
Уникальные технологии, созданные российскими специалистами. Такой нейрошлем помогает восстановиться пациентам, которые перенесли инсульт. Еще одна система способна распознавать голос. Техника сбережет время врачей.
С помощью голоса надиктовывать протоколы, а не писать.
Чтобы обеспечить масштабный рывок, в России подготовили профильную национальную стратегию. В мире идет борьба за технологическое лидерство.
Если кто-то сможет обеспечить монополию в сфере искусственного интеллекта, ну, последствия нам всем понятны. Тот станет властелином мира. Не случайно многие развитые страны уже приняли свои планы действий по развитию таких технологий. И мы, конечно, должны обеспечить технологический суверенитет в сфере искусственного интеллекта.
У России хорошие стартовые условия.
So just to give you a heads up, so in case you don't know, that's the leader of the Russian people. He's arguably a dictator at this point. And then let's go ahead and take a look at the Chinese president, who no longer has term limits, so he's also arguably a dictator.
Meanwhile, President Xi also stressed upon the importance of speeding up the development of artificial intelligence in the country. He said AI was an important driving force in the country's new round of technological and industrial development. He said there needed to be more innovation with a special focus on developing its core technologies. The Chinese president also stressed upon the importance of basic theoretical research in artificial intelligence so that China can stand at the forefront of key areas in the field. He said the country should further combine AI with the goal of industrial development to provide new growth drivers for high-quality development. And the country should also combine AI with the goal of improving people's lives, be it at home, work, or school.
So I think that's pretty good evidence that, yes, the human race is going to invest a lot, not just money, but also other resources into developing a strong AI. It's not only got money behind it, but we got power behind it, and we have the capacity to build the computers that can handle it. So now that we know that there is a push to develop strong AI, I want to talk about next is to think about what is the limit of intelligence. So in this chart here, we've got an ant, right? And if you can imagine that this line represents the level of intelligence. So you see an ant over there, maybe a monkey is here, here we are as humans. Well, what makes us think that we are at the top of what maximum intelligence could be, right? And then the next question is, well, how high could it go, right? And at what point does something get so smart that it's like us to an ant, right? Ants act almost completely on instinct, right? Monkeys, we keep them in the zoo. They live in cages. What would something up here think of us? What would something up here treat us, right? How could we even comprehend? How could a monkey comprehend, much less an ant, what we do? So if we can accept that, then we need to be very worried about what we do when we build these artificial intelligences and as we work to build them to be smarter than we are. And so when we get to human level intelligence in an artificial, we call that the singularity. And this will be the last video.
It can make it easier for political groups to shut down negative speech against them. It can make it easier for businesses to assert their rights over interests of workers, consumers and the general public. Philosopher Nick Bostrom expressed concern about what values superintelligence should be designed to have.
A biological neuron fires maybe at 200 hertz, 200 times a second. But even a present-day transistor operates at a gigahertz. Neurons propagate slowly in axons, 100 meters per second tops. But in computers, signals can travel at the speed of light. There are also size limitations, like a human brain has to fit inside a cranium, but a computer can be the size of a warehouse or larger. So the potential for superintelligence kind of lies dormant in matter, much like the power of the atom lied dormant throughout human history, patiently waiting there until 1945. In this century, scientists may learn to awaken the power of artificial intelligence. And I think we might then see an intelligence explosion.
Any type of AI superintelligence could proceed rapidly to its programmed goals with little or no distribution of power to others. It may not take its designers into account at all. The logic of its goals may not be reconcilable with human needs. The AI's power might lie in making humans its servants rather than vice.
So the last thing I wanted to mention was, if that kind of got you a little worried, the one solution that I propose is genetics, and that was the last slide. I believe if we use AI to improve ourselves, we can avoid worshiping our new AI gods. Any questions? Yes. You can't. So the AI would know exactly where you are all the time and would be able to not only know where you are in that current moment, but derive where you're planning on being in the future. Yeah, they're doing that now with what you want to buy. So if you remember back to the Amazon video, one of the heuristics, which is a way to figure something out in like a shortcut that Amazon uses, is AI to say, okay, there's a new super popular movie for tweens, that's teenage girls, and so this bathing suit, because it's summertime, was very popular. And So they'll get that to the warehouse and have it prepared to be purchased even before you go to buy it. Yeah. Isn't that crazy? Say that again. Louder, please. Yeah. So genetics is a code that allows you to create a human being as well as other living organisms. So it's a big data problem, which AI is really good at handling big data. We take our advances in AI and put it in that field, in that industry, so that we can make ourselves better. For example, the limitation of our cranium. What if we make our cranium bigger? What if we make our brain denser? What if we can figure out how to make connections better in our brain? If we can do stuff like that so we can keep improving ourselves at a rate that is above or at least equal to the rate we improve AI, I believe we have a chance. I like that better than Elon Musk's solution of connecting with them. I don't know if I want to put an AI in my brain. That's just me. Does that answer your question? All right. All right. If there's nothing else, then thank you for your time.